I'm going to add this as a second video here for example number 1. And the reason that I'm going to do this is because I think that it'll help you to see this graphically as far as being graphed out by a computer program or your calculator. So here's my function. What I'm going to do is I'm going to pull up Maple. I mean, you could use any program that you wanted to graph this, but I'm going to plot that function. So we're going to do x here is my theta, so that's my variable. I could really use whatever I wanted to here, but for my x values, let's go from negative pi to 2 pi. This is really irrelevant, it's just a preference thing. And then for my y values, I'm going to go from negative 2 to 2. That way we see all the graph. And I'll just switch the color around just so that, and the thickness, so that it's a little bit bigger. And I'll have to end my parenthesis here. Okay, so there's my this is the cosine function here, okay, of that final graph. What I want you to notice, and if I go back to let's say negative pi over 3, what I want you to notice is that the point that was normally here got shifted back to the left. I'm going to graph as well in here. I'm going to do the parent graph, which is just cosine. Okay, so I'm going to graph the cosine function here. I'm going to put that in red. So the original function will be in red. So here's the original graph in red. So notice it goes down, okay, comes back up, and so this is, you know what, let's do it like this, so that we can switch back and forth. I'm just going to plot both of them. So one thing that you can do in Maple is you can set it to graph just like one function at a time here, and then we can display them both. So let me show you. If you're fast forwarding through this part, I don't blame you. Okay, so here is here's the original cosine function. Okay, so that's the cosine function. Now notice that I start up top here, I head down, and then I come back up, and I repeat myself every 2 pi. Now, if I put on top of that function, if I display them both at the same time, I can put the new function, which is that cosine 3 theta plus pi. Now what I want you to notice is that the blue function is the new function. It's happening much more quickly. Okay, it's jumping up and down here. And I want you to notice that the y-intercept was moved backward. And the amount it's moved backward is by pi over 3. So we have this movement back. Now, if I take that 3, so if we go back here, let me show you on the so this is what I've graphed. This is the guy in blue, okay? Now, I'm going to graph this guy in green. So let's graph another function. I'll call it it doesn't matter what I call it. We'll call it g. But if I graphed cosine of theta plus pi, the movement is going to still be to the left because it's positive, but it's going to be to the left by a full pi, not pi over 3. Oops. So let's go back here, and let's take a look at that graph. So if I take out that 3, so I'll do this in green now. Now, and actually, let's move all the way back so I can see this whole thing. Back to negative pi. The green graph, if I extend it, the red graph was the original. The green graph got moved back all the way to negative pi. So I want you to see that without that 3 in front, we'd move back all the way to negative pi. But with the 3 in front, okay, we move back to just negative pi over 3.